Applications of differentiation. In this video, we are going to continue with maxima and minima problems. You will find this on page 298 in the Namibian AS-Level Mathematics textbook, y equals mx+c to success. Let's look at another example. The diagram shows the cross-section of a hollow cone in a circular cylinder. The cone has radius 6 cm and height 12 cm. And the cylinder has radius r cm and height h cm. The cylinder just fits inside the cone with all its upper edges touching the surface of the cone. Express h in terms of r and hence show that the volume of the cylinder is given by this. Okay. We are going to make use of similar triangles. So we take this picture, just want to get a pen. We take this picture and we make it two-dimensional. Okay, so if that is 12 and that is 6 and that is h and that is r, that is of the cylinder. So that piece will be 12 minus h, that 12 minus h, and yes, that's R and that's H. Okay, so in triangle ABC, let's see, ABC, this big triangle is similar to ADE, this smaller one. So AB over AD is equal to BC over DE. Okay, so where you have information. You don't have information here, so use the sides where you have information. Okay, now just go and substitute in. This is the 12. There is I substitute. I cross multiply. I get this. And then I make H the subject of the formula. So the volume, okay, so what is the volume of a cylinder? It's pi, it's area of base, so it's pi r squared times height. Substitute h in this formula. That's what I did there. And then I get this. And this is what they showed me there. Okay. So again, the constraint is the cone, but the one that can vary a little bit is the cylinder in it. Okay. Now, given that r varies, find the stationary value of f. So if I see stationary point, stationary value, I just know I must differentiate. So dv over dr, and I differentiate, I get this. So always for stationary point, dv over dr will be 0. So I go and I put this 0, I take r out. Okay, so r is 0, this is 0, so therefore, now r cannot be 0, then it's not existing. So therefore, R will be 4. Reject, there would now be no cylinder. And then given, find the value for the V. So now I just go in this, take this value of R, and in my V, I just substitute it, and I get, you can keep it in terms of pi. So 64 pi, or 3 significant 201 cubic centimeters. Okay. I want you to stop the video and I want you to do number 1 and number 2. You can continue the video as soon as you are finished. Number 1. The diagram shows a cylinder of height h and base r centimeters inscribed in a cone of height 24 and base 10 centimeter. Okay, express h in terms of r and hence show that the volume is this. So it's more or less the same. So the only thing, I'm going to take this picture and I'm going to get it two-dimensional. So let's do it here on the side. Okay, there is my triangle. And there is this. Okay, and now I'm just going to fill it in. I think I'm only going to use yellow. So it's going to be, oh, my pen. It's going to be A, D, E, B, C. Okay, let's fill it in. This is going to be R. This is going to be 10. This is going to be H. Okay, and this, I have to take a pen to do that. From there to there. This is going to be 24. So this part here, and I can even do it like this is going to be 24 minus H. Okay. Okay, there it is. Okay, and I have everything. And now I can say, okay, I'm going to make use of similar triangles. So I can say triangle ABC, the big one, is similar to triangle ADE. Okay, now I'm going to work with the sides. Now remember, it's always very easy. It's the first two over the first two. I'm going to write all 6 down just for explanation's sake. Then it's the last two over the last two. Then it's the first and last over the first and last. But now, I don't have any information on AE and AC. So basically, for this example, I'm just going to work with the first two. Okay, I don't want to scratch it. So if I'm working with this two, then I'm just starting to fill in. In the place of AB, I put 24. In the place of AD, it's 24 minus H. In the place of BC, I put 10. And in the place of DE, I put R. Okay, now I just cross multiply. So I get 10, 24 minus H equals 24R. Okay, so basically if I'm going to multiply this in, I'm going to get 240 minus 10H equals 24R. But I must make H the subject. So I think it's better to take it over because it's negative. That's why I take it over. Then I divide by 10. So therefore, I get H is, this will be 24 minus, and I can just simplify this, divide by 12, by 2. So it's 12. So if I divide by 2, I get 12 over 5. And it's R. You can leave the R there. Okay. Now, this is H. This is now in terms of H. But now, don't forget, what is the volume of, because I want to optimize the cylinder inside. So I'm going to start with the volume of a cylinder is area of base times the height. Okay. So now I'm just going to substitute the height. I have the height. So it's going to be 24 minus 12R over 5, close the bracket. So if I'm going to multiply this, I have to work to their point. So actually they want me just to bring R in. So leave the pi because I must get this. So I'm going to multiply this in, so it's 24, just the r squared. And this is going to be 12 over 4, 12 r to the power 3 over 5. Okay, and that will be my final answer. Okay, now let's just go to number B. Okay, given that R varies, find the maximum volume of the cylinder. Now always, if I see maximum, minimum, it's differentiation, it's stationary points. Okay, so in this case, I think I'm going to just rewrite this. I'm just going to first, let's just see. I'm going to first, I'm just going to differentiate. So dV over dr. This pi is just outside, so it's almost like just a constant. Okay, it's just running with that. If it was a r, you should have multiplied in, because you are differentiating to r. But because it's just a constant, you can leave it outside. So if you multiply there, you will get 48 r minus, this is again just a constant. So I'm going to do it here on this side. So it's going to be 12 over 5, and then let's multiply with that 3 over 1, and then you subtract, so it's R2. So do you see? So 12 times 3 is 36 over 5, and this is why I'm going to say 36 over 5, and I subtract 1 from the r, so it was r squared. And keep it, the pi is running with them. And now I can say at stationary points, dv over dr is equal to 0. Okay, so basically I'm going to just put that's equal to 0. I'm going to, yes, because I'm going to just redo this step. I prefer in this step to make it a little bit easier. You can do it without. I'm just going to multiply it in. It's maybe unnecessary, and I'll show you why. But just it's just better. Otherwise, you have to think of the brackets and everything. Okay, and now if I'm going to, so now I'm taking r out. Otherwise, I sit with the pi also. So I have 40, because it's almost like I'm solving x, but now I'm solving r. Okay, so it's 48 pi minus 36 over 5 pi r, because one r is out. I'm factorizing it. Can you see that? And then I have r is equal to 0, or I have that 48 pi. If I put it equal to 0, I can take this over 36 over 5 pi r. Okay, so basically, I just want to see quickly. I'm just going to divide to get r alone. I'm going to divide by 36 over 5 pi, 36 over 5 pi. So if I press it on the calculator, 48 divide bracket 36 divide 5, close the bracket, equals, and it's 20 over 3. That's what I'm getting. 6 2/3. So the pi's cancel, so therefore this r is 6 2/3. And that will be in centimeter. So this one, I can just say reject Why? Because if there's no r, if there's no length, if there's no distance, then this cylinder is not existing. Okay. Okay, it's not this one, it's the one on top. But this is the same principle. Okay, so just let's refer to the so if r is 0, then it's not existing. Okay. Okay. And now, I said find given that x can vary. Okay, I'm not there. I'm at the, I want to say R. It must be R. Given that R varies, find the maximum value of the cylinder, volume of the cylinder. Okay, let's just go up. And now I'm just going to find the maximum volume. So say maximum volume and I'm just going to substitute in this. Okay, and now if you're going to press that on the calculator, you can first keep it in terms of pi. So I'm going to press it just to show you how I press. So I'm going to say 6. I like always to start with the fraction. ABC 2, ABC 3 times the 48 equals minus, and put a bracket. Say 6 ABC 2 ABC 3 times 36 ABC 5. Oh, I made a mistake. I should have squared. Okay. I don't know how to work with mistakes. Okay, so let's just start again. If I'm saying, I'm taking time, I could have just wrote down the answer because I have the answer. Let's just try to do it again. Okay, so it's 48 multiply 6 ABC 2 ABC 3. Close the bracket. Oh. Okay, minus bracket. I'm first going to go for the square, so it's 6. The problem is this. This is the problem. I think it's better. I'm wasting time. Okay, 320. Make this 320. That's 320. That's unnecessary struggling. Okay, so, and I know especially you can press, especially the youth of today, you are very good pressing on calculators. Bracket 6 ABC 2 ABC 3 close the bracket square equals multiply 36 ABC 5, and that's equal 320. Okay, I want to see 350. So it was, oh. I just want to see if I'm substituting in the right formula. Because in this case, let's just redo this step. I want to just see, because now that I'm checking, I want to see if I'm busy substituting in the correct formula. Okay, I'm not substituting in the correct formula. I'm supposed to substitute, see, in this formula. Oh, there's my mistake. Okay. This is the volume. This is the different in the original one. This one. Okay, let's start again. Okay, so I like sometimes in the videos to leave the mistakes and then just to correct the mistakes. Otherwise, I could have just do the video over. Because I think sometimes you make them same mistakes. And then, because usually if you make a mistake, you will not make that same mistake again. So for this, in the next number 2, I will not make this mistake again. So this was the formula. And it's actually, I know why. It's very good to first write down the formula. I didn't write it down in the previous attempt. Okay, so if I'm going to do it now, so now I'm going to say pi 24, and then it's 6 and 2/3 squared minus 12 over 5, and it's 6 and 2/3, and it's the power of 3, and I close the and I still don't want to give up on my calculator, so a bracket 6 ABC2 ABC3 close the bracket square, multiply the 24. I'm just going to put it in steps, so it's going to be a bit easier. Otherwise, every time I press incorrect, I have to redo it. 6 ABC2 ABC3 close the bracket to the power 3 equals times 12 ABC1 equals minus 7, 1, 1, and 1 over 9. So it's 1066 ABC2 ABC3 minus 711 ABC1 ABC9 the bracket equals. Okay, let's write again. Okay, I'm just trying it again. Okay, at last. It's always bad if sometimes the easy thing takes you so long. Okay, so this was the easy thing. So the answer was 3, 5, 5, and this is in terms of pi, cubic centimeters. Or if you want to get rid, you're just going to multiply and multiply with the real price, shift pi equals, and then correct to free significance, it is 1, just want to see, 117, 3 ones. And that it's actually not correct to free significance. I would say correct to free significance will be 1120 cubic centimeters. Okay. Okay, but I think keep it in terms of pi, it's exact, and it will always be the correct answer. This was quite a long sum, so but let's go for the next one. Let's go for number 2. Okay, let's look at example 2. In the diagram, S is the point 0, 12. Now, this is very important. If this is 0, 12, what it's actually saying is that this distance is 12. And T is the point 16, 0. So what it actually saying is that this point is 16. The point Q lies on ST. So the point Q lies on ST between T and has a coordinate XY. Again, what it's actually saying is that this is X, this distance there, and this distance there, or there, it doesn't matter, is Y. Better to write it here, because if I then must find this distance, SR, it's going to be 12 minus Y. That's going to be the green there. Okay. The point on X respectively. And OPQR is a rectangle. Then show that the area of the rectangle is given by this. Okay, it's almost the same as in this example. We were taking just the two-dimensional out in this example. In this example, they are just giving it to you. So we're also going to make use of similar triangles. So we're going to say that triangle OST, and I'll show you now, is similar to triangle ROE. SQ. So let's just see. Okay, what I want you to see is that, okay, say this triangle is similar to this triangle, but it's very, very important the way you name it. So if these two triangles, the big one and the small one, are similar, we say that I know that this angle is as big as this angle. Okay, this angle is similar. And this angle is as big as this angle. So when you name it, you must name it according to the similar triangle or angles. So if O is similar to R, I have to start with R. And then I go to S, which is common for both. And then I go to Q, to T, and T is the same as Q. Because if you don't do it like that, you cannot go into the next step. Because the next step, you are saying the first two, O is, I'm going to put over that first two. Then the last two, ST, I'm going to put over this last two. And then the first and last, I'm going to put over the first and last. And now I must see where I have information. Now I don't have SQ, and I don't have QT. So it means this one will go out. So I'm actually just left with OS. I just work with two at a time. And now I'm just basically going to substitute. So in the place of OS, I'm going to put 12. I'm just going to use another color. Okay, let's use the yellow. That's all right. I'm going to put 12. In the place of RS, where is RS? RS is that green. I'm going to put 12 minus y. In the place of OT, I'm going to put 16. And in the place of RQ, let's just see, where is that now? RQ, I'm going to put X. Okay, and then I'm going to cross multiply. Now, if I cross multiply, I get 12x is equal to 16, 12 minus y. Okay, now, I'm going to, let's just first multiply it out, then I'll tell you. So if I say 16 times 12, I get 192 minus 16y. Okay, now, in this case, what did I always make the subject of the formula? H. Do you see? So what am I going to make now the subject of the formula? Y. Because at the end, I want it in terms of x. I want to actually get y in terms of x, so that in this formula, there's only an x. So if I take that over, I get 16y. I take it over because it's negative and I want it positive. And then I divide by 16, divide 16, divide 16. And I get y equals 192 divide 16. I get 12. And then I simplify, divide 3, so it's minus 3 over 4x. Okay. Now, the area of a rectangle. So, the area of a rectangle okay, let's write a rectangle OPQR is equal to area is equal to that x multiply y, length times breadth. Okay, so I have x, and what is y? Let's just move it up. Y is 12 minus 3/4 x. And that's going to be 12x minus 3/4 x squared. Okay, that's what I got there. Excellent. Now I will go to number B. given that x can vary, find the stationary differentiation always equal to 0 of a and determine its nature. So if I'm going to say this is now for the area. So I'm can just say dA over dx is equal to 12 minus, it's actually just, I'm just going to write it here. But that is just going to give me 12 minus, it's going to be over 2. So it's just going to give me that 3 over 2. Because go in 1, 2. Okay. Now, and I'm moving it up again. For stationary. For stationary points, dA over dx is equal to 0. So I'm just going to say there 0 equals 12 minus 3 over 2x. I prefer taking this one over because it's negative. And then I'm just going to divide 3 over 2, divide 3 over 2. Okay. And then I'm going to get, let's just see what I get here. If I put it, I get 8. Let's just see. It's equal 12 minus 3 over 2. Okay. So let's see if I'm correct. It's 8. So therefore, x is 8. But that's not, I'm not done with the sum. I should have written better there. Okay, and then I go on. Given stationary and determine its nature. Okay, so let's first go and say what is the, oh, and now I'm not going to make the mistake as I did in the previous one. It's actually always that one that you substitute in. It's that you can even write it from your question, not the differentiated one. And that's going to be 48. Okay, but now for the stationary point, I'm going to say, let's just take another color. I'm going to differentiate this again. So d square a over dx squared, that's a constant becoming 0. So it's just negative 3 over 2. And that is smaller than 0, so it's negative. So therefore, it is a minimum area. So find the stationary value. That is the stationary value. And then I'm going to say if this was in centimeters, let's just check. Question was in centimeters, or they never gave me units. And if they never you can just, if you want to put a unit, just say units square. Okay, because it's area. And this is because it's negative, it's going to give you a minimum stationary point, so it's going to be a minimum area. Okay.